Hi, everybody. Welcome to this talk. I'm Sébastien Deleuze. I work for Pivotal as a Spring Framework committer, and I'm also taking care about Kotlin support in various Spring projects. And I'm a conference organizer. I organize Mixed conference in France with friends of mine. So today we are going to talk about a new Spring project, which is called Spring Foo, which will integrate some forward-looking stuff, but we are going to talk about where we are with Spring and Kotlin right now. A quick safe harbor statement, because I'm going to talk about various forward-looking stuff that may or may not happen. So on Kotlin side, the rise continue. It's clearly driven by the Android adoption. So Google chose Android as the main and official language for Android, and obviously a huge number of developers are currently switching from Java to Kotlin. That move is super fast on Android side. On server side, it's also increasing, even if that's smaller. But we clearly see that even if we can discuss the fact that I took the questions on Stack Overflow to show this increase, the trend is pretty clear. And Kotlin has recently overtaken Scala with these figures. If we put things in perspective, we see that Java is still far away, but it seems to me that the future is quite clear. We are going to have on the JVM two main languages. Java will stay the major one, but Kotlin begins to be a real challenger, and other alternative language will stay below. And that's a pretty new situation on the JVM. For me, Kotlin allow Java developers to leverage their existing skills to write shorter, safer, and more expressive code, and that's pretty new. I mean, in Scala World, for example, you had to learn a new ecosystem, and you were not always able to leverage your Java skills, where in Kotlin, I tend to think it's more possible. Kotlin is also a way to really have a better signal to know the ratio when you write your code. You have the Kotlin version at the left and the Java version at the right. That's a very simple example. There is not only data classes in Kotlin, but really we see that when times come to write, but also to debug and to read and to maintain your code, I prefer to have to maintain the version at the left than the version at the right. And that's one of the reasons why Spring provides first-class support for Kotlin, introduced in Spring Framework 5 and Spring Boot 2. So nowadays, you can totally use Kotlin as a drop-in replacement for Java and write your Spring Boot application and your Spring MVC controllers, leveraging the same annotation-based programming model, and you will be able to write shorter code, more expressive code, and I think that's pretty interesting. If you have not started yet with Kotlin, I advise you to start on try.kotlinlang.org to train yourself and learn the language. That's a pretty nice in-browser editor when you can train and learn the language. Also, Kotlin in Action Boot is pretty nice one. And for the Spring side, I have put everything. So every thing you need to know about Spring support for Kotlin is in this Kotlin tutorial. So you go to spring.io, you go to the guides, search Kotlin, and you will see a pretty complete tutorial, which is about building a Spring Boot 2 application with Spring MVC and Hibernate using Kotlin. And that's why I advise you to use right now if you want to do Kotlin on production. But today we are going to talk about more forward-looking stuff. So we recently introduced Webflux with Spring Framework 5, which is a reactive web framework available in two flavors. The first flavor is the one you already know. It's annotation-based. So the principle is to reuse the regular annotation-based programming model you know with Spring MVC. But we use that with an underlying non-blocking and reactive engine based on Netty, Jetty, or Undertow. You can choose the engine. You use reactive or asynchronous types, so I'm talking about Flux and Mono from Reactor, I'm talking about single and observable from Eric Java, or even raw completable future from the JDK, but you are basically leveraging asynchronous or stream type to write your non-blocking application. But in addition to this annotation-based programming model, and that's perfectly fine to use that, we also introduced a new way of programming that. It's with functional API. And this functional API go pretty well with some Kotlin DSL. So this is something that is right now available in Spring Boot 2 and Spring Framework 5. It's describing your web routes with a DSL where you can combine request predicates. So request predicates who, for example, specify the path, the content type, and you can combine these with AND or not operators, and then you specify the handler. That's just a sample, but this is right now available in Spring Boot 2, and that's while working on this stuff that I was asking myself a few questions that I would like to share with you today. One of these questions was, what if we apply this kind of Kotlin DSL to Spring Boot configuration? I mean, when we are using that, we are using a kind of functional and DSL for the router part, but everything else is annotation. So I was wondering if we could extend this model to Spring Boot configuration. One other question I was asking to myself was, what if I prefer declarative configuration to enable only what we need? I mean, Spring Boot is awesome. It has pretty smart auto-configure, which allow to configure features based on class path detection, for example, or based on various conditions. But some people prefer to have full control on what they use. And yeah, maybe some people want to prefer declarative configuration instead of auto-configuration. One other question I was asking to myself was, can Spring application be more efficient by leveraging functional bin definitions instead of Java config? Because historically, at the beginning of Spring, the bins were defined with XML. Nowadays, everybody do Java config with add configuration and add bins in your Spring Boot application. I guess you already do things like that. But in Spring Framework 5, we introduced a new way of declaring your bins, and that's the most efficient one. That's using lambdas to define your bins. And that's what I'm going to show you after. And the last question was, could coroutines make Spring Reactive Stack easier to use? We will go deeper in detail into that later. So that's to answer to this question. I introduced a few months ago Spring Foo. So Spring Foo is an incubator intended to contribute features related to Kotlin and functional configuration to Spring Framework, Boot, and Data. It's not designed, at least that's not the current goal, to be really a top-level project. It's more an incubator for forward-looking stuff that are not ready yet to go to Spring Framework, Spring Boot, and Spring Data. But my goal is really to make all these features available later into the top-level project. You are already using that, and really keeping Spring Boot as the single entry point for all the Spring Galaxy. One of the main, maybe the most important feature of Spring Foo is Kofoo. So maybe you don't like the name or you like them. It's just me. I chose that randomly. But basically, Kofoo is for Kotlin and functional. Okay? So it's configuring your Spring Boot application with the Kotlin DSL in a functional way. And it's a DSL to configure Spring Boot, and we are going to see an example. So when you are building a Spring Boot application with Kofoo, you are still creating your application with the main. Okay, there is no Arc because I'm using Kotlin 1.3 for people that are already doing Kotlin. And like I had this routers DSL, or like I have the bins DSL in Spring Framework 5, I'm introducing a new DSL, which is application. So I'm going with this DSL to describe what is the configuration of my application. And this DSL will contain sub-elements that will allow me to configure various parts of my application, the web part, the data part, etc. The nice thing about this DSL, it looks like a document, so you can see it's like YAML, XML, JSON documents, but in fact it's Kotlin code, so that means you can put debug point, you can put breakpoint, you can put if or for statement, any kind of code. So it's at the same time a document and at some times of codes, and you get full autocomplete, etc. So I'm going to do a demo of that. So I'm going in my IDE, and I'm going to build a Spring Boot application with Kofoo. So the first thing to understand is that I'm really leveraging Spring Boot infrastructure. I mean everything except this dependency, which is the Kotlin DSL, is really typical Spring Boot application. I'm using the starters, I'm using the embedded MongoDB support, I'm using everything you are used to use on your regular annotation-based Spring Boot application. But I'm going to use another kind of way of configuring it. So I'm creating my application, okay, so I'm writing that. I'm going to have my main, okay? And everything here is going to be configuration of my application. And the nice thing is that I have autocomplete because this is Kotlin code. I am in my IDE, so I can configure the login. I can say, okay, I will configure that. And you see that very naturally, my configuration of my application is very discoverable. I don't have to read a lot of documentation and go everywhere. I'm just using that. So here I will just keep the default, but just to show you. I have access to my documentation inside my IDE. So again, I don't have to go everywhere in terms of documentation. Everything is documented via KDoc, which is a Kotlin version of Javadoc. So you don't have to go outside. And via autocomplete, and really I'm loving autocomplete, you have everything available. And Kotlin extensions make that thing quite extensible because in Java world, it's very hard to do this kind of DSL, fluent DSL thing in an extensible way. So usually you have something which is provided and you can't change it, except by using static methods or interfaces. While with Kotlin extensions, I make that DSL extensible even for you in the ecosystem if you want to provide for your library some configuration for this Kofu DSL. It's possible by using Kotlin extensions. So we are going to configure that. So let's add, we are going to add an equivalent of configuration properties, but in the functional world. So that's just syntactic sugar, but basically I'm declaring my sample properties. I'm declaring here I'm going to declare my sample.message equals hello, okay? So this is really the functional equivalent of functional properties. And here I'm going to specify properties, sample properties, and you can see that I can leverage Kotlin features like name parameter, for example, to make my code more readable. So here I'm just using that sample. I'm going to introduce the repository part. Okay, so I'm going to add a repository. I'm going to add this user document. So this is quite close to what you will do in the annotation-based world. Here, since I'm using Kotlin and Spring Data Kotlin extensions, I don't want to use an interface where the implementation is automatically generated. I think the code in Kotlin with all the extensions is super short, that I don't need to do automatic generation of the implementation-based interface. So I just use this plain reactive MongoDB operation-based code. And I'm going to add a configuration. So the nice thing is that with this kind of DSL, everything is still modular. I mean, it is not about creating a monolithic configuration thing where everything is in the application. You can build like you have your add configuration classes that you can put everywhere. You have this kind of configuration block. And in fact, application, if you have a look, so everything is discoverable. So if you want to understand the DSL, you just have to go to the source code. And you can see that the application is also a configuration. Okay? So in this data configuration, I'm declaring the bins that are only relevant for the data parts. If you don't like declaring things explicitly, you can still use bin scanning, okay? You can still do that. You can also provide implementation. You can create the instance of your bin directly with the bin supplier. Here, I'm creating a listener that will react on the application-ready events and that will initialize the data. And here, I'm declaring explicitly that I want to use a MongoDB server, and I could customize I can customize some various things, but and here I'm using the embedded support. Okay. Okay. So I need to say explicitly that I want to use it because it's not really a convention of our configuration model. Here, everything is explicit. So I think that's pretty short, but you have to specify explicitly that you want to use this data configuration. There is nothing that comes by surprise. You declare things explicitly. I'm going then to create my web configuration. So here, I'm going to add this and also my handlers. So take the time to see what's going on here. So like for the data part, I'm declaring the bins that are only relevant for the web configuration. With the annotation-based programming model, we had this controller which combines the routing and the handling part. And in functional world, we are going to declare the router. That could be also an external function. So here, I'm declaring my routes. And then it points with function references to the handler. And here you can say that I will return a response HTTP OK. I render an index template. And I put as model attributes users and message. I think I need also to put my mustache template here. I'm declaring also, again, nothing is coming magically from the class path, so I will declare that I want to use mustache for the rendering. For codecs, that's also interesting because here again, I will configure that explicitly. So instead of having some default codecs configured based on the class path, like on regular Spring Boot application, I will configure explicitly that I want a string codec, a Jackson codec, if I want to use a protobuf codec that I added in Spring Framework 5.1, you can also. So everything is on your control. Here, I'm getting a reference on user handler, but if you want to go inside, that's just a super thin layer on raw Spring Framework API. If you go to ref, it's just an alias for context.getBeans. So if you go inside, you will see that's a very thin layer based on functional and Kotlin DSL on top of low-level Spring API, and that's why it's pretty fast. So here again, I need to import the configuration because it's explicit. I think that should be fine. So I'm going to run just my main. It's just a simple application like that. Okay, so you see that's a regular Spring Boot application that starts, okay. I'm going to my browser. Okay, so here I have my mustache template that is rendered. Here I have my JSON rendered, and that's the raw data. And for example, if you want to change the configuration, I mean, if I want to, this DSL is pretty extensible because Jackson is just declared like that, but if you want to configure things, okay, you go to the Lambda, okay, init output equals true. You can also configure other advanced properties. Everything is discoverable. I restart my application, and I will just check that this update is taken in account. And you see here, I have pretty print, and everything is fine. So really, this principle of getting the configuration discoverable is super important. So back to the slides. Okay. So in a nutshell, Kofu configuration, it's an explicit configuration of Spring Boot infrastructure via Kotlin DSL. It is based on Spring Boot infrastructure used in a functional way. No features are enabled by class path detection. It's both declarative and programmatic. It has faster startup and lower memory consumption than a regular annotation-based Spring Boot application because it is based on functional bin definition, which is a very thin layer on top of low-level Spring API. It uses minimal reflections, minimal annotation usage, pure Lambda, no CGLib proxy. We don't even need this Kotlin Spring plugin when you are using regular annotation-based Spring application. You need, and we automatically configure on start.spring.io a Spring plugin which will automatically open the Spring annotated classes because for CGLib it is necessary. Here, we don't need that because we don't use this kind of mechanism. But what about Java? Because when I show that to people, I heard a lot of Java developers that say, okay, Kotlin is super sexy, you can write this nice DSL, but I'm still in the Java world, and I would like to leverage this kind of explicit thing, go faster, etc. So I introduced Jafu, which is the same thing for Java, so Java functional. And it's just only a POC for now, but in the coming weeks, I plan to reach feature parity between Jafu and Kofu. So the principle will be to provide this kind of DSL with an optimized version based on Kotlin DSL, it leverage extensions, and also another version for Java, which will be more verbose, but yeah, I mean, it's up to you to choose the language, and Spring is about giving you the choice, so we will provide you that choice, at least on Spring Foo for now. I would like to talk also about coroutines. So coroutines are a feature of Kotlin, which are lightweight threads. So think about creating many thousands of threads, and that will consume nothing. It's supported in Kotlin, and that allows to run non-blocking and asynchronous code. So I have provided this kind of comparison between Reactive API and Coroutine API. So for single values, in reactive world, you will write a method that returns mono or single if you use RxJava, or if you are just using JDK, think about a method that returns completable future, okay? And this, in coroutine world, will translate as a suspendable function that returns T. The nice thing here is that you don't have to use any wrapper to provide this kind of asynchronous feature. You are using this capability of the language to specify suspend, and you don't have to wrap your method, your return type into a wrapper, so that avoid to leak that too much into your code base. For streams, there is not yet support for call streams in coroutines, but that will come in the next month, I think. And for hot streams, so call streams are basically a kind of reactive collections. So it's something that have a finite number of elements and that you want to get as they come. When you are returning a suspendable function that returns a list, you have to wait that all the list is available to begin to process it. With cold streams, you can begin to process elements as they come. Hot stream is basically subscribing to listen tweets, for example, or this kind of thing, and that's supported via a receive channel. And for that use case, I tend to think that reactive is still super useful because you have to use a wrapper, so I prefer to use the most powerful one, which is the reactive one, I think. So coroutines are a way to leverage Spring Data reactive stack, web and data, with a style close to imperative programming. And I think for simple use case, I mean, you want to build a simple CRUD application based on our reactive stack. You don't necessarily need all the power of a reactive API. That's a pretty good use case. So coroutines are stable in Kotlin 1.3. Channel API is still experimental. And I'm currently incubating that into Spring Foo. And official support is expected in Spring Framework 5.2 and Spring Data Reactive. And now the last topic of the talk, it's about GraalVM native images. So GraalVM is an experimental VM project from Oracle, R&D. So it contains a part where it's just a new VM. So that basically you run your application with Java, and you have an alternative VM which internals are more written in Java. So instead of C in hotspot, so they have been able to provide more optimization and evolve that. But there is a super interesting sub-project in GraalVM, which is called Substrate VM. And Substrate VM compiles JVM application to native executables like Go. So it's really about compiling your application that usually run in the JVM, but you will not need any kind of JVM. You will just have an executable, potentially statically linked, so you can deploy it on from scratch Docker images, and that's all. It's a pretty fast startup. We are going to see that in a demo in a few minutes. It has low memory consumption because you don't have to use a whole VM to run. It is maybe less suited theoretically for long-running jobs like for servers because you don't have this VM that do runtime optimization. But based on the figures, it seems it performed pretty well. So GraalVM is quite young, especially the Substrate VM part is super young, so don't expect to run your application right now in production. It's super early. They need to fix a lot of things. So yeah, the ecosystem really also need to adapt. So there is a part of the work to be done on GraalVM. The ecosystem need to adapt because this is basically a new way of running Java application compiled. So you can expect that it's not straightforward and there is some things to adapt. And we provide early support for that in Spring Framework 5.1. So another demo maybe. So this is a project. So this is a regular Spring Boot application. Okay. So this is really a minimal one, because when I say that not everything is supported, I can't provide an example of Spring Boot application using annotations and a lot of starters that will run without any modification into GraalVM. That's our goal, and I think the GraalVM team want to support that, but we are not here yet. What I'm going to show you, that's a Kofu-based minimal application with a native web server that renders some JSON or some templates. So you can see that it starts pretty fast, but that's a regular application that runs with Java. So now we are going to compile it with GraalVM. So when I say compile it, we are going to use some configuration file. So we are going, just want to show you. So basically you need additional configuration because GraalVM will analyze your bytecode, try to see what class you are using, and if you are using any kind of reflection or do some advanced stuff, you need to say to GraalVM, okay, keep these classes because I need them at runtime. So there is this kind of configuration. And I'm going to run this script, which is really building the application building this application with GraalVM, with the JVM, and in this case that will be GraalVM. Unzip the jar, and then I'm using native image. Native image is the tool provided by Substrate VM to compile your application into a native executable. So you will see that the compilation takes some time. It's like when you compile a C program, when you are building your kernel on Linux or this kind of stuff, that takes some time. So I begin, just before I want to show you something. So I have to use the JDK provided by the GraalVM project, okay? So here I'm using GraalVM 1.0 RC7. Then my program is compiled with a so this is not the Java-C from the regular JDK. This is Java-C modified version of Java-C from the GraalVM project, okay? And then I'm extracting the jar from Spring Boot, and I'm compiling my main and dependency with image, native image. And here it's fun because I'm compiling my project, and you can see the logs that provide. In fact, the tool is currently analyzing the bytecode, and it's converting it to native code. And while doing that, it runs basically internally the program, and you see the logs, etc. So it takes some time. Like I said, it's not something that you will use to debug your program. Okay. I think it takes something between 20 and 30 seconds for the compilation part. Obviously, running the application will be much faster. Okay. So now we can see that I have an executable com.sample.application.kt, and if I run it, you can see that I can run a Spring Boot application in 16 milliseconds. So it's something that we can run. Okay, here it's 6 milliseconds. So when I say instant startup, it's because everything is done at the compile time, and then you have a real. It is based on Java ecosystem. It's using Spring Boot. It's using Kofu configuration. It's using Netty. It's using Jackson. But it compiles into something that is similar to the executable you have in Go world. You can see that it's basically 50 megabytes because you have the application and all the dependencies and the JDK, and we will be able to optimize that further. But it's pretty nice to have this kind of application. It's consumed at I think 30 megabytes of resident memory. So also the memory consumption is much more optimized. The use case where I think this is interesting is for serverless and this kind of thing where you want to maybe spend less money on the cloud by just shutting down your application when there is no request. With this kind of almost instant startup, you can basically really trigger your application when you receive a request, where historically JVM was not the best technology to do that compared to Go or Rust or other technologies. So I'm almost at the end. In terms of roadmap, I plan to continue to incubate SpringFu the Kofu and the Jafu configuration, include some security DSL, and provide a wider support for all the Spring Boot capabilities. Be aware that my goal is not to support everything that Spring Boot supports, so I will focus on the reactive stack because I tend to think that coroutines allow to consume this reactive stack in a more imperative way. We are going to work on a Spring ClassPath filtering Gradle plugin that will allow to only use a small part of Spring because Spring is really well organized, and here we are just using a small part of Spring. So the idea will be to limit the ClassPath available to only the functional stuff and the reactive stuff. On Spring Data side, we are going to support reactive SQL, and also I will provide coroutine APIs based on what we announced 2 weeks ago at Spring One platform, which is R2DBC. So R2DBC is basically a reactive equivalent of JDBC, and we are working on that and plan to provide production-grade support, for the moment, for PostgreSQL for next year. So there will be some coroutine SQL API based on a truly asynchronous core available production-ready next year. And on Spring Framework 5.2, which will be released next year, also coroutine support for Webflux, for R2DBC, improved GraalVM compatibility because we provide initial support, but the road is still long to get every kind of Spring application supported. And also a light reflection for Kotlin, because Kotlin is super well optimized because it was designed for the mobile world, but there is a place where Kotlin sucks. It's for reflection. The Kotlin-reflect dependency is basically half of the compiler. It consumes a lot of memory. It takes some time when you start the application. So we have complained about that to JetBrains, and we are working with them, and they have provided a light reflection API, which will allow to fix this issue. So we would like to use this replacement for the big and fat Kotlin-reflect dependency. Last feature, we are going to contribute Gradle Kotlin DSL support. So Gradle, a few years, maybe 1 or 2 years ago, announced Kotlin support for Gradle. So in addition to the Groovy DSL that is historically used in Gradle to configure your build, they are providing a Kotlin DSL which will be final in Gradle 5, which will be announced in a few days, I think. So we intend to provide official support on start.spring.io. So in addition to Maven and Gradle Groovy DSL, you will be able to use this Gradle Kotlin DSL in order to write your build and your code in Kotlin. Thanks a lot. You can follow me on $. The project is available on GitHub, so feel free to have a look. Feel free to contribute. We have already 10 external contributors. It's pretty easy to provide some pull requests to improve that. It's still experimental, so it's maybe easier to provide something here rather than directly on Spring Framework on Spring Boot. And if you have some questions, feel free to ask. Thanks.
Okay, so we have several questions.
Okay.
I can ask you only 2. And others, please find Sebastian and ask your questions. So the first one, about reference. So you show ref, just to get a user handler, and you show that it used getbean, and someone, anonymous, said this usually bad practice. I'm not sure is it bad practice or not, but can you comment on it?
Yeah, no, that's not a bad practice. I mean, in the annotation world, you are expected, if you are building a Spring Boot application, you are expected indeed to use injection, constructor-based injection or field injection, this kind of thing. But internally, we are using getbean to translate that. So in the functional world, it's the same. Instead of using @bin, @inject, constructor-based injection, we are going to provide you the possibility to get a reference explicitly on the bin, and that's just the idiomatic way to do that. So there is nothing wrong using that in that kind of model. And you don't write getbean yourself, okay? I'm not exposing here directly application context. I'm just exposing a DSL where you can call a ref, and that just me internally, I have shown you the implementation of the DSL, and internally I'm using getbean, and that's perfectly fine. And when you are using the annotation-based programming model, that's what Spring do inside. It just here, the layer is super thin, and I just have to do one click to go to the get bean, while on the annotation-based programming model, it will take more click, and it's not as discoverable.
Okay, good. Graal is awesome, but do you have any issues integrating Kotlin and Graal?
Specific to the integration of Kotlin and Graal, no. There was initially, so they fixed, I think it's in Kotlin 1.2.60 or something like that. They fixed some things because there was something broken in the bytecode. But right now, I have not a single Kotlin-specific issue. So every issue we have on GraalVM is something that is common to Kotlin and Java. There is nothing specific. The bytecode generated by Kotlin is pretty clean. I mean, we know that. It comes from the Android world. Everything needs to be statically typed. And yeah, the bytecode generally generated by Kotlin is super clean, so we don't have any issue about that.
Okay, thank you.
Thanks. Don't hesitate.
I think you're free to find Sebastian and ask questions about Spring and Pivotal. Yes?
Sure. Feel free to come and discuss.